Hey guys, welcome back to another video, and today we're going to be working with solving for square roots with like variables and like square root equations. So let's go through the first example. So we have 10 minus n equals the square root of n minus 4. So let's go ahead and let's solve for this. So how do we solve for this? So if we have something like x squared, if we want to get rid of the x squared, we have to use a square root and we'll get x. So if we have x squared, we can go to the x using the square root. Likewise, if we have the square root, right, and we want to get rid of it, we can just raise it to exponentiate it and we get x. So we're going to do that here. We're going to raise both sides to the 2. So when we do that, this cancels out and this cancels out. It's a property. So we get 10 minus n equals n minus 4. Now from here, it's just algebra. We're going to add 4 here, add 4 here. So I'm going to get 14. 14 equals 14 minus n equals n. I'm going to add n. So I get 14 equals 2n. I divide by 2, and I get n is equal to 7. So let's plug it into our original equation and see if this works. So we're going to get 10 minus 7 equal 10 minus 4. So 10 minus 7 is 3. So square root of 3. And what am I doing? And a 7, sorry. And then equal the square root of 3. So that means this n is a solution. N is our solution. So let's try another one. So if we have 10 equal to x plus 4, let's go ahead and solve for this by raising both sides equal to 2. This cancels, so we get 100 equals to x plus 4 minus 4, and we get x equals 96. So if we do 10 equals to the square root of 96 plus 4, we get 10 equals to the square root of 100, and 10 is equal to the square root of 100, which is 10. So that means this is correct, and x is equal to 96. Let's do one where we have extraneous solutions. So the extraneous solutions is when we do that squaring thing, when we're solving something like this, we get an extra solution. And when we do that, that solution, that x that we solve for, works for the thing without the square root. So like if we had an extraneous solution here, it would work for this 10 minus n here, not the square root of 10 minus n, because the square root of 10 minus n has or square root in general has a domain restriction, which is the inside can't be a negative number for an even root. So if, for example, if we have 30 minus 7x equals to x, and we go ahead and we solve this, so this goes away. This becomes 30 minus 7x equals to x squared. Move everything to the right so we can so we can factor. So we get x squared equals, x squared plus 7x minus 30 is equal to 0. So this is what times negative 30 and adds to 7? Let's see. So 30... x plus 10. So then we set each one equal to 0. So we get x plus 10 equal to 0, and we get x minus 3 equals 0. We can solve for x now to get our roots, or our zeros for our function, and we get x equals negative 10, x equals 3. So now let's plug in each one into our original equation and see what we get. So we're going to get 30 minus 7 times negative 10 equal negative 10. I'm plugging the first one. So we get 30 minus 7 times negative 10 is going to equal to 70. So we're going to get 30 plus 70 equals to negative 10. So this is going to be 30 plus 70, which is going to equal to 100. So negative 10. And the square root of 100 is 10. And is 10 equal to negative 10? It is not. So that means that x equals negative 10 is extraneous. Okay. So let's try another one. Oh, I'm not done. Let's try the other one. Let's try positive 3, which is right here. So if we do 30 minus 7 times 3 equals to 3 into the original, not into the one that we changed when we squared, we're going to get 30 minus 21 equals to 3. 30 minus 21, I believe that's 9. So 9 equals to 3. Square root of 9 is 3, so which is right. So x is equal to 3. Let's try another one. So if we have square root of x plus 5 equals to x minus 1. Let's go ahead and square both sides. So this is a quantity, and we squared it with the FOIL. When it was just like x squared, like before we would just make it x squared, but we have to actually FOIL out this time. So we get equals x minus 1 times x minus 1. First is going to be x squared minus x, and then it's going to be positive 1 equals to x plus 5. X plus 5 is equal to x squared minus 2x plus 1. We move the x and the minus 5 to the side. So we're going to get minus x minus 5. So we're going to get 0 equals to x squared minus 3x minus 4. So we're going to get, what times to negative 3 and, what times to negative 4 and adds to 3. So, so 0 equals x plus 4, no, x minus 4. Correct. And if we go ahead and we FOIL this to make sure, we're going to get x squared plus x minus 4x minus 4, which is x squared minus 3x minus 4. So our factors are correct. So if we do 0 equals x minus 4 and x plus 1, we can use the product property, 0 product property, and we're going to set each one equal to 0. So we're going to get x minus 4 equals to 0, and we're going to get x plus 1 equal to 0. And we can go ahead and solve for x here. So we get x equals 4, and we're going to get x equals to negative 1. So let's plug in each one into the equation, which is originally the square root of x plus 5 equals to x minus 1. So let's plug in 4, see what we get. So we're going to get 4 plus 5 equals to 4 minus 1, plugging everywhere where I see an x. So the square root of 4 plus 5 is square root of 9 equals to 4 minus 1. Square root of 9 is 3, and 4 minus 1 is 3, so that means x equals 3 works. Let's try a negative 1. So if we plug in a negative 1 for x, we get negative 1 plus 5 is equal to negative 1 minus 1. So we're going to get negative 1 plus 5 is 4, so we're going to get square root of 4 equals to negative 2. So square root of 4 is 2. Is 2 equal to negative 2? It is not, so that means x equals negative 1 is extraneous. And x equals 4 is our solution. So let's try another one. So if we have 6x plus 15 equals to x plus 4. Let's go ahead and square. So we can get rid of the square root. So we get 6x plus 15 equals to x plus 4 times x plus 4. So I'm going to 4, I'll get x squared plus 4x plus 4x plus 16 equals to 6x plus 15. I'm going to simplify and set equal to 0 so I can factor. So we get x squared plus 8x plus 16. Move the 6x and move the 15 to this side and to this side. So I get 0 equals x squared plus 2x plus 1. So x squared plus 2x plus 1 is equal to 0. So we can factor. So what times to 1? It adds to 2. So it's going to be x plus 1 squared equals to 0 because it's going to be x plus 1 times x plus 1. So now we're going to take the square root again. So we get x plus 1 equals the square root of 0, which is just 0. So we're going to plug it in, and we get x equals -1 for our solution. And we're going to see if this even works. So our original equation was 6x plus 15, the square root equals x plus 4. So if I plug in the square root of 6 times -1 plus 15 equals to -1 plus 4, I get -6 plus 15 is equal to 3, because -1 plus 4 is the same thing as saying 4 minus 1. So -6 plus 15 is equal to 9. So we get the square root of 9, which is 3. So we're going to get 3 equals 3, and it satisfies both sides. So that means x is indeed equal to -1. So let's try this one. 5 equals to 5 times the square root of 3p. The first thing we're going to do is divide, because it's 5 times the square root of 3p. So we're going to divide, and we're going to get 45 divided by 5, which is 9. So 9 equals the square root of 3p. And we're going to take the square root so we can get rid of it. So we're going to get 81 equals to 3p. We're going to divide by 3. And we're going to get p equals to 81 over 3, which is, what is that? 27. So I'm going to plug it back into the equation and see if it works. So we're going to get 45 equals 5 times the square root of 3p. So 45 equals 5 times the square root of 3 times 27. So 45 has to equal 5 times 3 times 27 is 81. Okay, so the square root of 81 is 9. So we do 5 times 9, and is 45 equal to 45? It is. So p is indeed equal to 27. And this one is extraneous. It's only one solution. So make sure you always check your answers with these. And yeah, this is how you solve square roots equations in general, whether they be extraneous or non-extraneous. But always checking just in case when you're squaring to make sure you have your solutions. Have a good day.